Audio Jungle.
Good day to you, viewers. Today, we will now discuss a simpler way to solve circuits with many loops. That is, we will be using Maxwell method, or also known as the mesh analysis. So to start off, let's take a short review of Kirchhoff's voltage law. Kirchhoff's voltage law states that the sum of the voltages in any closed loop is equivalent to the sum of the potential drops in that loop. So, for the mesh analysis, what we do is make simultaneous looping around closed loops, in which all loops are in the same direction, and we formulate equations such that we can solve them simultaneously and find values easily. For us to better understand the mesh analysis, let us have this example. So we have a 1.5 volt DC source in parallel with a 100 ohm resistor that is also parallel to the 9 volt DC source, which is in series with a 200 ohm resistor. So again, for this problem, we will have to find the voltages across the 100 ohm and the 200 ohm resistors, and the current passing through the 1.5 volt DC source. So what we do is simply make a loop around each closed loops in the circuit. The number of equations you will need will be depending on how many unknowns you have. Thus, will depend on the number of loops you will make. Hence, will depend on how you will obtain the equations. So we again make loops around the left and right part of the circuit. So we will have this as loop 1, and this will be loop 2. So here is where the crucial part is. So we must always remember when making equations, we must put into mind that in a closed loop, when the current travels from the negative to the positive polarity, the voltage is negative. However, if the current travels from the positive to the negative polarity, the voltage is positive. So the equations will be, so for the first loop, we will have 1.5 minus 100 times the current in the loop 1 and the current in the loop 2. And we will equate that to 0. Simplifying this equation, we will have negative 100 current of the first loop plus 100 I2 is equal to 1.5, or negative 1.5. So for the second loop, we will have negative 9 plus 200 I2 plus 100 times I2 minus I1 is equal to 0. Simplifying this equation, negative 100 I1 plus 300 I2 is equal to 9. So we have this first equation and this the second equation. Equating this would yield us, for I1, we will have 67.5 milliamperes, while for I2, we will have 52.5 milliamperes. But we can see that the current passing through the 100 ohm resistor is the difference of the currents in I2 and I1. So we will have at I100 ohms, I2 minus I1, it is equal to 15 milliamperes. And that the current I2 is also equivalent to the current of the 200 ohm resistor, which is 52.5 milliamperes. And again, by Ohm's law, we can have the voltages of V100 is equal to the resistance, 100 ohms, times 15 milliamperes, which is 1.5 volts. And for the 200 ohm, we will have 200 ohms times 52.5 milliamperes, we will have 10.5 volts. And again, applying TCL at either of the two nodes, above or below, will give the current passing through the 1.5 volt DC source equal to 52.5 milliamperes. Now, for us to further understand and reinforce our knowledge on mesh analysis, we will now consider this example. Now, as you can see from this example, we are now considering an inductor and a capacitor. So, first, we have to find the equivalent impedance of the capacitor and the inductor. So first, we will use this formula to find the impedance for the capacitor. That is 1 over J omega C. Substituting the values, we will have J times 1000 times the capacitance, that is 0.04 farads, and you get the reciprocal. Next, using the formula for the impedance of the inductor, we will have J multiplied by the angular frequency times the value of the inductor. We will have J times 1000 multiplied by 0.04. We will just simply have 4J volts. And upon simplifying this, most probably we'll have negative 0.25 J ohms. Now put these values into this circuit. Now, let us move on to the mesh analysis. So first, we take the loop here, and the loop here. So, let this loop be I1, let this loop be I2, and this be I3. So for loop 1, we will have 10 angle 0 degrees minus the 1 ohm resistor multiplied by I1 plus minus another 1 ohm resistor multiplied by the difference of the currents between I1 and I2, which will be I1 minus I2, and then passing through the 0.04 farad capacitor, which has this impedance, we will have minus negative 0.15 G multiplied by the difference of the currents between I3 and I1, we will have I3 minus I1. And simplifying and fully forming a loop, we then equate this to 0. Simplifying this equation, we will have 10 angle 0 degrees minus 2 I1 plus 0.25 G I1 X plus I2 and minus 0.25 J I3, which is equal to 0. Next, combining similar terms, we will have 10 angle 0 degrees plus negative 2 plus 0.25 J I1 plus I2 minus 0.25 J I3. And this will be our first equation. Next, considering loop 2, we will have negative I2 plus I1 minus 4j, 4j I2 minus 1 times I2 minus I3, and again we have completed a loop and we equate that to 0. Simplifying this equation, we will have I1 plus negative 2 minus 4j and plus I3. Let's equate that to 0. And this will be our second loop. Next, considering the third loop, we will have negative I3 minus I3 plus I2 plus 0.25j I3 minus I1, and then we equate that to 0. Simplifying the equation, we will have negative 2 plus 0.25j I3 minus 0.25j I1 plus I2 is equal to 0. And that will be our third equation. Now, solve the system equations numbers 1 and 3, we will have equation 4. That is, the simplified will yield negative 2 plus 0.5j I1 plus 2 minus 0.5j I3 equal to negative 10 angle 0 degrees. This will be our fourth equation. Next, solving systems number 1 and 2 simultaneously will yield equation 5. That is, when simplified, will give 4 plus 7.5j I1 plus negative 2 plus 0.5j I3 will be equal to 20 plus 40j. Now, we only have two equations and two variables. Solving these equations simultaneously, we will have I3, which is equal to 5 over 17 minus 20 over 17j amperes, which is also equal to the current through the 1 ohm resistor on this far end. So we let that as Ix. So we can now write Ix as 5 over 17 minus 20 over 17j amperes. Now that we have found Ix, which has this value, we can now use Ohm's law in order for us to find the voltage across the 1 ohm resistor at this far end. So, by using Ohm's law, we will have to use the formula V is equal to the current times the resistance. That is, the voltage X is equal to this current 5 over 17 minus 20 over 17j amperes multiplied by the 1 ohm resistor. And solving this equation, we will have Vx, which is equal to 1.21 angle negative 75.96 degrees volts. Putting this into time domain, we will have Vx is equal to 1.21 cosine 100t minus 75.96 degrees. which is what it is